Hello, welcome back to my series on probability and statistics. And in this section, we're going to be answering three different questions using the normal distribution. The first question is the probability x is less than some value a. The next question we'll do in a different color. Let's say green. The probability x is greater than b. And the third question, the probability x is between a and b. All right. So the first thing we're going to do is we're going to draw the standard normal distribution because that's what we're going to use. We're going to assume that x is distributed normally with mean zero and a standard deviation and a variance of 1. So we're going to draw this probability density function, which is our standard normal bell curve. And it looks like this. And then we're going to draw something new, which is going to be the probability function. So this first bell curve is the probability density function. And then this one is the probability function. So two different things. So this is the probability of x, and this is the probability density function of x. And then this is x here, and this is x here. So the first thing we're going to note is that we're going to put an a somewhere over here. We'll say that this is a, and this is the PDF of a. This is a density point. We don't actually want to know the density point of a because the density point of a is not the probability of a. The problem is since the normal distribution is a continuous distribution, we can't ask the question what's just the probability of a because it has no mass. But what we can do is we can ask what's the probability that a random variable will land on a or less. And this area value is actually some value on our probability curve. So this is the probability that x is less than or equal to a right here. All right, so why is this happening like this? Well, this comes from the fundamental theorem of calculus. And the fundamental theorem of calculus states that if I have some summation, some integral, some area under a curve like we have here, over some defined interval, we'll say from a to b, and we have some probability density function of our random variable, this is equal to the area under the curve all the way up to b. So the probability x is less than or equal to b minus the probability x is less than or equal to a. And we'll see why that makes sense. The other formula we're going to use is, so this is the fundamental theorem of calculus, and the other formula we're going to use is that the probability of a complement is equal to 1 minus the probability of a. So what this means is that the probability x is greater than or equal to b is equal to 1 minus the probability that x is less than or equal to b. And actually, let's do away with this, and we'll do away with that. Okay, so we've answered the first question. One second. We've answered the first question here. What is the probability x is less than or equal to a? Actually, you know what? Let's do that in green. We'll put a check mark over here in green. Good. Okay. The probability, it's greater than b. So we'll put b here, and we're looking for this area right here. Well, this is the 1 minus the probability x is less than or equal to b. So that's 1 minus the probability that x, let's grab a different color. So we'll put this here in purple. That's the probability x is less than or equal to b, and we'll put b here. And so it's 1 minus that purple mark here. So that solves this one. And then last, we're going to do the probability of that x is between a and b. So what that is we're going to take this area in purple minus this area in white because we actually only want, let's do that in blue. So in blue, let's see, that was this light blue. We actually want this section here. So we want to do purple minus white here to get this light blue area. So what we have here is this one is the light blue one. So using the fundamental theorem of calculus and understanding the difference between a probability density function and a probability function, we can calculate the probability that x will be less than a value, greater than a value, or between two values. It's important to note that a standard normal distribution is typically written as z. So the z distribution table is all of the values on this curve associated with all of the x values. So you'll say, what's the probability? What's the probability z is less than or equal to some fixed constant? And that will be the table. You'll look at your z value, and then you'll find your probability, and that'll be the area to the left of some valued point. Then all you have to do is use these formula to find your answer.